Hole 44, the hole of a lifetime, 108 meters of 11.7 grams per ton gold. We're off to the races now. Jewelry box, where all the value is concentrated. And in this case, gold is concentrated in a very small area, and the jewelry box model shows why the gold is there.
Hole 44 has the highest grade gold interval ever recorded at Atlanta, 108 meters of 11.6 grams per ton. There's a 29 meter intersection of 37 grams per ton. And within that, there's a 3 meter section that's running above 150 grams per ton.
Now, that's about 1.25 ounces per ton. Now that is something that's your jewelry box, right there. It's important to hit, first of all, and then further define these extremely small but high-grade zones because they have a significant impact on the overall resource calculation. You're concentrating in a very small area at that thickness, that 30-meter thickness in there. Within just 10 meters this side, 10 meters that side, 10 meters this way, 10 meters that side, that's a lot of gold in a very small area. If you can take and track these things 10 meters or 20 meters at a time along these structures and keep adding, before you know it, you've got a lot of gold in just a very small area that you didn't know about. You had no idea that was there. That has a huge impact on the economics of a open pit deposit, especially an oxide deposit now. This is all oxide mineralization we're talking about. These things are so hard to find. You normally find them when you're mining the deposit, which is why open pit oxide gold deposits typically get higher grade once they are mined, because you find all those little boxes scattered all through the deposit that you didn't know about. I'm now strongly suspecting Atlanta's going to be very similar. Typically, the so-called jewelry boxes occur at structural intersections like we drilled into. So this was not necessarily by accident. We're following already a grade trail that's leading us to what we hoped would be a higher grade pod, and that's what we hit. That jewelry box is called a boiling point. This is the source for the surrounding mineralization. And this is what we want to hit. Everyone wants to hit these things because the grades are so high that they can take a previously uneconomic deposit and turn it economic, just like Amax Gold did at the Sleeper deposit in northern Nevada many years ago. Just one hole turned that entire company and deposit around. When I saw the assays, I knew that we had the potential at Atlanta for multi-ounce mineralization elsewhere. Not just necessarily at the Atlanta deposit, but within the entire district. When you hit something like that in one part of the caldera, you've got chances for hitting more of it elsewhere. And that's really what we got into Atlanta for. We're looking for a monster deposit. And high-grade hits like hole 44 are telling us we've got that potential. I mean, it's difficult for me to convey how strong an impact intercepts like this have, if you can prove that they have lateral continuity to them. That we have to prove that. And that's what we'll be doing next.
Very early on, Cal recognized that the prevailing thought on Atlanta was incorrect, and that's that the model that everybody had drilled on was not, in fact, the model that should have applied to the project. When we picked up Atlanta, it was not the most exciting project. It had been explored heavily. There was a significant amount of gold, but probably not enough gold with where it was located in order to get people excited. And the limiting factor was that people thought there was a single vein that was responsible for depositing all the gold.
The original model was a single fault plane dipping about 45 degrees to the west. It is anywhere from 10 meters up to 30 meters thick in places. And it pinches and it swells along the dip of the structure. That's the model that Kinross, Goldfields, Meadow Bay all drilled on, was that general model. Very simple, single structure, no internal structure in it.
In that setting, only so much gold can be deposited. And Cal went through systematically and looked at all of the past results, and he didn't think that that was correct.
Usually you don't start out drilling a deposit thinking at the very beginning that what you eventually wind up with is something that you thought you would find all along. If you do, you're probably going to miss and walk away from a world-class deposit. That's how you miss. You've got to go in with open eyes, open mind, with what we call the multiple working hypothesis, which allows you to jump around to different scenarios to see which scenario fits what your data is telling you. And it wasn't until we drilled the holes on the south end of the pit where we found this does not dip at 45 degrees, it dips at 5 degrees to the west, not 45. We put enough holes down, we defined it very, very well. And at that point, we knew we had a problem with the original model. We had to throw that model out the window, and then we had to go back to basic data gathering, basic geology, to build a new model that fit our results. And what we come up with is a horizon that dips gently to the west and has been broken by a series of north-south and east-west faults, which have formed the plumbing system, the conduits for mineralization that feed into this horizon that's in some places gets up to be 130, 140 meters thick.
We now are seeing multiple parallel fault structures that can in certain areas braid together, cross-cut, and it's at those intersections where you can get really phenomenal blowouts and jewelry boxes. Every fault is another possibility for gold fluids to have channeled up towards surface from deep down. And so having a single fault versus multiple faults is the difference between potentially having a small deposit and having something much bigger.
Now that's the revelation here, is that we have multiple pathways of mineralization, multiple occurrences of high grade along these pathways that are feeding gold and silver into this system over a very large area. And now it's allowed us to concentrate our activities along these fluid pathways to build the grade in a deposit that previously it didn't have the potential for grade out there because you didn't have the feeders. You only had one structure, not half a dozen structures like we have now.
The fact that this hole lines up with Cal's model bodes very well for confirming the model and hence being able to replicate it. And what I mean by that is if we had hit this hole and could not explain why the grade was there or how it formed, that could be the anomaly where it's hard to replicate. In fact, what's happened here is everything that Cal has been saying has actually come to fruition. We drilled at an area that is an intersection between two perceived veins, and sure enough, where those fluids came up, you got a blowout of gold. We know that other areas like that exist, and we've had other very high-grade intercepts.
The hole spacing we've been using in the West Graben target area has been about a 100-foot or a 30-meter hole spacing. Now what we have to do is step off of those holes a little bit to see if we can't hit the jewelry box. Extend that jewelry box further to the north along trend. It just means you've got to put some closely spaced holes across there to try to find the sweet spots.
Now that we have found this ultra high grade, there's going to be a little bit of focus on looking for areas where we can find more of them. It's one thing to have a theory, it's another thing to have that backed up by a drill result of this caliber. So our focus is certainly going to turn a little bit to, hey, where are the areas around Atlanta where we've hit very high grade that happens to be near intersections of major faults? And can we go back there and spend a few drill holes trying to locate another one of these?
It's going to change what we're going to do here. It's going to change priorities. We're going to have to reallocate resources, but with a discovery like that, you just can't sit on your heels and do nothing. You've got to get out and you've got to actively look for more. There's a bright star hanging over Atlanta right now, and it still remains to be seen how brightly that star is going to shine down on us. But my suspicion is they're going to see something much brighter, much bigger in the coming months as we continue to push these high-grade envelopes around different portions of the deposit. Once you start scattering these jewelry boxes around a deposit, it's not just in one place, it's in many places, and at that point, the deposit takes on a different life. And this hole 44 shows us we have great potential for this thing to take on a very different life. The story of mines in Nevada is largely a story of serendipity. The drill results are pointing southward.
What we've seen through our drilling is the likelihood that we're going to see an appreciable increase in the grade